Okay, so now we're dealing with trig. Now, trig, I think a lot of people think of as triangles, right? That's all you've done in trig now, up to now, is basically triangles. Well, this unit, we're going to be talking about the circle. Now, there's tons and tons of angles in a circle if you start from the middle and then you go all the way out. So here is the unit circle that you're going to be using this year. And here's all the information that you're going to have to know, and we're going to have to add some to it. But you'll have to know this quite well for your unit test, okay? And you're not ready for it yet because we have tons of stuff to learn today, okay? So I'm just showing you this just to scare you, okay? No other reason but to do that. It's working, obviously, so she looks like she's going to throw up. Okay, now let's start just talking about all those definitions that always come up. Now there are lots for this unit, and by lots I mean a lot, okay? Now the first thing we're going to talk about is angles in standard position, okay? Now standard position, now first of all, angles can be measured in degrees with 360 degrees as a complete rotation. Now, we're going to think of the clock a lot, right? Because the clock is like that. The second hand goes 360 degrees in 60 seconds. The minute hand goes 360 degrees in 60 minutes. And the hour hand goes every, how long? 12 hours, not 24, right? Every 12 hours it does a 360 degree angle, right? So, I want you to think of the clock when we're doing these, but your clock starts and finishes at 3 o'clock, okay? So this is what we would call our initial arm. Then we rotate counterclockwise. So that's how it's different from a clock. See how the second hand's going? It is going like this. We will be going counterclockwise, okay? So this, it was initial arm, and then it did a rotation in the positive counterclockwise direction. Now, a positive angle is counterclockwise. A negative angle is clockwise, okay? So that may not seem intuitive right away. But believe me, after you use this enough, and that's what repetition will help you learn these better and better. So positive is counterclockwise. That diagram there would be a positive rotation angle because it started at 3 o'clock and moved up. Now, we say this is in standard position because basically it starts at 3 o'clock. Okay? Now on the coordinate grid, standard position means the initial arm is along the positive x-axis and the rotation is about the origin or the vertex. Okay? Now the origin, because this is 0.00 here. Whenever we do a graph, we're going to be always calling the center 0, 0. Okay? So those are a lot of definitions right now. A rotation angle is when you start from the initial arm and you go through about an angle, a fixed point. Now, positive, negative, vertex, terminal arm, and initial arm. You have to know all those definitions so far. Okay? Now, this one's in standard position. Now, this one here, this is a 220 degree angle. So you start at 0. So I can even draw one. Let's draw one here. If I started here. Okay. And if I went like this, I went 220 degrees. So you start here and you go all the way around, and that would be 220 degrees. So you start at 3 o'clock and you do a positive clockwise rotation to 220. Okay, now let's talk about the next thing, and that is our quadrants. Okay, now what quadrant would this be right here? Does anyone remember? What quadrant would this be? 3. Good. It goes 1, 2, 3, 4. You remember that? Okay. So it's usually done by Roman numerals, but I will just do it this one time. Usually I just write the numbers, right? So 1, 2, 3, 4. So 120, where would that be? Where would 120 be if I was, so I'm starting here, okay? 120, which quadrant? Second? Where would it be? Oh, don't do that. I don't want to move you. Bad. There you go. I would like to be, there's 90, there's what, 100, 110, 120. Yeah, somewhere around there. Again, you don't have to get your laser protractor out to do these. You just want to kind of sort of guess. Okay? So this is how we would, this is 120 degrees. 309, which quadrant? 4. Okay? So 309 would be around here somewhere, right? So it's in quadrant 4. How about 17? Quadrant 1. Okay? Now, most of us are very visual when we do these. So you're always going to want to take the time to draw out the question instead of just skipping the question and going right to the answer. It will improve your mark greatly. Okay. Now, the next thing we're going to talk about is what we call coterminal angles. Now, obviously, do you see them there? Are they this, this, and this? Look at them. Are they the same angle? Yes. But we can call them different things. We could call it 150. Right? That is the positive rotation. We can also call this negative 210. Because when you go the other way, that is a negative. Write this stuff down. You also can go like this. You can go 510 degrees. Now, how would I get back there again? What do I do to need to go back again? Guys, how many degrees? No. If I want to get there one more time, what would I do? Add 360. So you see, if you keep adding 360, you keep going back to the same place, right? Sometimes you'll hear people say, I've heard them on, movies or documentaries or something like that, and they, maybe they got over some addiction, right? Or they, used to do this, and now they do this, and they go, yeah, I made a total 360-degree change in my life, and now I'm doing this, right? Because they don't think about it. If you made a 360-degree change in your life, how much change have you made? 0, okay? The correct term is 180 degrees, okay? But people will make that mistake. I've heard it a few times, right? 360 means you've done absolutely nothing, okay? Now, have you ever seen like a dog? Sometimes they get in and they do a few turns and then they lay down. Have you ever seen that? Does anyone know why? Because they're watchdogs. Get it? They're winding up. The laughter is going to be just awesome at home. Okay, I got another math joke for you. What do you call it when your parrot escapes? When your parrot escapes. Yes, a polygon. Get it? Okay, good. Okay, let's get back. So, these are all called coterminal angles. Now, co means to cooperate, means do it together, and they all terminate in the same place. Okay? To cohabitate means we all live together, right? To coterminate means we all end in the same spot. So there is an infinite way to say one angle, right? That angle, add another 360, add another 3. I mean, you can add 360, right, till you're blue in the face. You can also subtract 360 and go the other way in a negative direction. So coterminal angles are all the angles that make that end up there. Those are all coterminal. I mean, look, they all, stop in the same place. It's pretty evident. Now, there is only one of them that is the principal angle. Now, the principal angle, another definition for you, is the smallest positive rotation angle. Stop there, okay? It is the smallest positive rotation angle. So, in our case, that would be example A. This is the only one that demonstrates the smallest positive rotation angle. Okay? Nothing else fits that definition. B is negative, so that's gone. And C, well, you went like around more than once, right? So you obviously aren't the smallest positive rotation angle. Okay? So, whole bunch of definitions so far, like about 10 already, okay? Now, let's go down and talk about points, okay, coordinates. Where's coordinate 2, -4? Now, it's really hard to answer these kind of questions, like draw the angle of 2, -4. It's like, what? Are you serious? What do you mean, draw an angle? I don't have an angle, I got a point. How do you draw an angle with a point? Well, you're going to get very used to doing this. You draw these, right? You are starting, right? Here's this is the 1, right? That's your, what's that called? X-axis. What do we call that, though? It's 0 degrees, yeah? It's called your initial arm, right? Now it's going to terminate at 2, -4. Picture it. 2, -4 would be, okay, so let's call that 2. -4 would be 1, 2, 3, 4. So it'd be about right there, right? So this is where it's going to terminate. So the angle would be this right here. And we're going to call that theta. Now just so you know, theta is like a circle with a line through it, and that's unknown angle. Not today, but you will be trying to find that angle in a couple days. Actually, more than that, because Monday we're going to get back at the unit. Okay, now again, -5, -1. So I draw that quick. 1, 2, 3, 4, 5. Remember, -5 is on that side of the 0. Here's 0, right? And then I'm going to go down 1. So that point would be about there. So we'll draw that. And that is my angle theta. Actually, I'm just going to put this right by the point here. Okay? That's how you'll be able to find the angle. Got it? Okay? So, I just want you to see all the definitions we have to know now. We have to know we need to know rotation angle, initial arm, terminal arm, vertex, positive angle, negative angle, what standard position is. Okay? I need you to know your 4 quadrants. I need you to know what coterminal angle is. I need you to know what a principal angle is. And I need you to know how to plot coordinates. That's in 2 pages, okay? This unit is thick with new stuff. So a study sheet is going to be imperative, okay? Now, next one, we're going to talk about reference angles. This is totally new for you as well. Now, the reference angle, remember these definitions are purposely made to mess with your head. It's an acute angle formed between the terminal arm of the rotation angle and the x-axis. Okay? Now, if you don't know where the terminal arm, rotation angle, and x-axis are, reference angle is going to be a little obscure. But the reference angle is, let's kind of take it in pieces here. It's an acute angle. What's acute? It's less than 90, right? Formed between the terminal arm. Terminal arm is like the second hand, right? That's going the opposite direction. It starts at 3. And the x-axis. So I want you to look at this diagram here. We have two things. We have a rotation angle and a reference angle. This is called the rotation angle, and it is 141 degrees. Okay, that's our rotation angle, ROT. Now, what is the reference angle? What's left? The rotation angle is the acute angle formed between the terminal arm and the x-axis. 39 degrees. Okay, that is called the reference angle because it is the acute angle formed between the terminal arm and the x-axis. Okay? Now the reference angle is extremely important to us. We are going to be using it a lot today. Okay? Well, this whole unit. Okay. Let's do a couple of these. We got, it says, in each case, draw the rotation angle and then state the reference angle. The rotation angle is 243. Where am I for 243? Which quadrant? Quadrant 3. So again, you don't have to have the old laser protractor out, just kind of like guess, right? So let's call that 243 degrees. Now, the reference angle is the acute angle formed between that blue thing and the x-axis. So this is the reference angle that I'm looking for. Does that make sense? It is the angle formed between the blue thing and the x-axis. What is that angle? Who can tell me what that angle is and how you got it? Yes? How'd you get it? Okay, now, why didn't you stop there? Because if you took this and subtracted 180, wouldn't you just get this left over? Yeah, but you don't want this. So it's 243 minus, oh no, sorry, yeah, 243 minus 180, right? 243 degrees minus 180, so the reference is 63 degrees. This is 63 degrees. That is the reference angle. Is it acute? Is it the angle formed between the rotation angle and the x-axis? Or the terminal arm, I should say, and the x-axis. That's 63 degrees. 337. Where is it? Okay. Again, just try to roughly draw it. So say it's there. Now, how can you find that little piece? Because everybody should know this is what I'm looking for. I'm looking for that. Yes? How? Okay, so if you go 360 minus 7, that is 23 degrees. So yes, that is 23 degrees. So do you see how we got to think about this instead of memorizing formulas, how to find reference angles. Because doesn't that make sense? How to find that? And don't let it stop making sense. I have people memorizing, oh, if you're in quadrant 4, always take 360 minus it. And if you're in quadrant 3, take that angle they give you and minus 180. And if you're in quadrant 2, do this. And if you're in quadrant 1, do this. I just draw it. Now, it may take me, like, if you memorize the crap out of this, you may be faster than me, but I'll be able to do mine in 3 months. Where you'll have to go, oh, crap. I used to have that memorized, but now I don't anymore, right? So drawing a picture, in the end, saves you time. If you can do it visually, it does save you time. Plus, let's face it, we only have so much room up there, right? Let's try and keep as little of there as we have to. Now, 70. 70 would be here. Okay? What would the reference angle be? Good. Now, just so you know, this is the angle sign. I always say that the ref angle, little angle, equals 70 as well. So then people memorize that, and they go, in quadrant 1, reference equals rotation. And it does. It always will, won't it? Because this is the rotation angle, but this is also the reference angle, right? Okay. Now, this one in the grid below, draw the reference angle of 58 degrees in each quadrant and tell me the rotation angles. So it's going backwards on us. Okay? So 58, pretty close to 60, right? So let's say it's there, there, there. Well, that one's not very good. Not happy with that one. There, and there. Okay? So I'm going to draw them because this is 58. This is 58 degrees. Put my degree sign there. This is 58 degrees. And this is 58 degrees. Now there is a way to memorize this, but let's not. Let's just kind of look at it. And let's do our rotation angles, okay? So what would be the rotation angle here? Would be 58 degrees. So again, like I said, rotation always equal reference in quadrant 1. It should. It makes sense, right? Quadrant 2. How would you find... Now remember what we're looking for. This is the first angle I want. This is my second angle. What is that angle? How much? How? Yeah, that'd be pretty confusing though. There's a simpler way. How do you find 122? Yeah? How? Forget? Yep. See if you go 180, 58, minus 58. See how that brings us back? So if you go 180, because 180 is all the way, minus 58, you get 122 degrees. And you'll learn that in quadrant 2, if you take 180 minus the reference, it always equals the rotation. Okay, that always works. Okay, in 3, how would I find all of this? So 180 plus 58 will always get you the answer. So it's 180 plus the reference, okay? Because this is the ref, right? So 180 plus 58 equals 238 degrees. And in quadrant 4, I am looking for this. 360 minus 58 equals 302 degrees. Okay? So again, you can memorize that. Quadrant 1, ref equals rotation. Quadrant 2, 180 minus reference. Quadrant 3, 180 plus reference. Quadrant 4 is 360 minus reference. Okay? Now, I don't have that memorized. If you asked me, I'd go like this. And I'd go, oh yeah, 360 minus ref. So that's how I would do it. Okay? Because memorization, it will fail you often. Okay? So if you're getting it wrong in a test, and I'm like, what? Oh, I must have memorized it wrong. I said, did you even draw it? It doesn't even make sense. Okay? So I think probably the answer to that would be no, I didn't draw it out. Okay, this one here. 5,8 is a point on the terminal arm of the rotation in quadrant 1. State the coordinates that would be in quadrant 2, 3, and 4. Okay, so let's draw this. Again, get a picture or else you're just going to be totally lost. So 5,8. 5,8 would be like 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. So let's say it's about there. Okay, so I want you to draw that. This is coordinate 5, 8, and I'm in quadrant 1. It says, well, give me the same reference angle in quadrant 2, 3, and 4. So what I'm looking for is I want the same reference. So this has to be the same as this. Would have to be the same as this. It would have to be the same as this. So what would the coordinates be in quadrant 2? Negative 5, 8. How about quadrant 3? Negative 5, negative 8. Quadrant 4? 5, negative 8. See, drawing the picture does make it a lot more understandable than all of that. Words. Those words, they get a little confusing. Now, do you see how those will all have the same reference angle? The same angle to the x-axis. It's got to be acute. It's got to be an angle to the x-axis from the terminal arm. Okay, so let's do, this says, here's your reference angle, 25 degrees. And they say do that in quadrant 2. They want to know what the rotation angle would be. So a 25 degree in quadrant 2 would look, I don't know, something like this, right? And here, it's so small, they're right in there, but that's 25 degrees, because the reference angle is the acute angle formed from the terminal arm to the x-axis. What would be the rotation angle? What is it? 155. How'd you get that? 180 minus 25 is 155 degrees. Okay? How about an 8 in quadrant 3? Well, an 8 in quadrant 3 would be your 8 there, right? That's my reference. What am I doing here? Should probably do the right question, eh? An 8 in quadrant 3. I made it a bit bigger. So this is right there. What would be the rotation angle? How do you get that? 180 plus 8 equals 188. Remember, the top one was 180 minus 25, and in quadrant 3 we go 180 plus, right? How about this one? A 90 between 3 and 4, huh? Okay, this would be a 90 between 3 and 4. See it right there? So what angle would that be? 270 degrees, right? Okay. Here is an excellent quiz question. Hint, hint. Okay? Determine 3 angles between 0 and 360 that have the same reference angle as a rotation of 256 degrees. Okay? Now, there's a lot of knowledge that has to go on here, and I'll tell you, without a picture, these things are hard. Okay? And you may, after I've done, you go, okay, I see how you do it now. Okay? It's one of those kind of questions. So first of all, we're going to draw a call them the crosshairs. Okay? Now, where's 256? Quadrant 3. So let's draw 256. Oh, maybe it's not that much. Yeah, I guess it would be, because that's 270, right? So let's, and we'll call this 256, right? Okay, that's 256. Now, degrees. Now, what I need to do is I need to draw all the other angles that have the same reference angle as that. What is the reference angle? How much? 76 degrees. Does that make sense? Yep. Okay. So, the reference is 76. How many other angles have a reference of 76? How many other? That would be all together. 3 more. So I want you to draw those quick, because this, oops, that's bad. This would be a 76er, right? This would be a 76. And I should be doing these in red. Do these all in red. Okay. And this would be 76 degrees. Does that make sense that all 4 of those have the same reference angle? So now it goes rotation, you got to go find reference, then you go you draw the reference, then you got to go from reference back to rotation again. So what other angles have the same reference angle? Well, in quadrant 1, what is that angle? So let's call this number 1. What is that angle? 76 degrees. In 2, what would be the angle? How much? 104. How'd you get that? 76, 180 minus 76 is 104. Okay, so that's 2. 3 they gave us, but if you really wanted to, just for continuity, 3 would be 256. So you don't need to do any work there. It's in the question. How would you figure out 4? 360 degrees minus 76 degrees, which is 284 degrees. Okay, so maybe that's not so bad now that you see it, but you want to be able to draw it. If you don't do a drawing, those are the students that are coming up. They're like, how do you do this? If you come up without a drawing, I'm just going to send you back to your desk and say, I want you to just draw it first. Okay, without a drawing, I can't help you. Okay, have the crosshairs, draw it in there. I could say, okay, this is what you did wrong. You drew it in the wrong quadrant, or it's, someone's phone not off? Or, okay, you can see how that interrupts the class though, right? Okay, so make sure that especially if you're a visual person, you get all of this stuff drawn out. Okay, so we'll do all, but do A, C, E, G's for them. Okay? And go.